Okay, welcome to Mobile Math. So in this lesson, we're going to do factoring polynomials, the sum and difference of cubes. Now this one's always difficult for students because there's a specific pattern that you have to follow when you're factoring the sum and difference of cubes. So it's something that you have to memorize. So I put that up here first, and we're going to talk about that. So if you have the sum and difference of cubes, first thing you have to have two terms, either a plus or a minus, and then both of these terms here have to be perfect cubes. So what do I mean by a perfect cube? Like the cube root of 27 is equal to 3. Right, so you have to have a perfect cube in order for that to work. What that breaks up to when you have that special pattern is this right here. So if you have the sum of cubes a to the third plus b to the third, you get this right here. Students look at that and they're just like, oh my goodness, how am I ever going to remember that? Well, let's talk about some little patterns or tricks that you might be able to use to remember that. First, if you look at both of them, they all have an a and a b first. Also, when you have the sum of cubes, the a and the b, it's a plus, so it's a plus b. If you have the difference of cubes, the a and the b, it's minus a minus b. Also, look at all of these signs in here. Each one only has one minus. The rest are all pluses. And the last term is always a plus, so it's always going to be plus b squared. So with that, if you go here and you say, all right, I got the sum of cubes. I know this has to be an a plus b because this is a plus, and then I know that the last term has to be a plus, and I also know that there's at least one minus in there. This has to be my minus term. And of course, these are the same a squared, ab, and b squared for both of those. Also, when you get here, this is a minus, so you know this has to be a minus b. And then you say, well, there's only one minus, so I already have it. So these two signs have to be a plus. Plus, you remember that this also, it's a b squared, it's always a plus in there. So there are these little tricks that you can use to remember. There are some other mnemonic devices that teachers will tell students or show students. Either way, you got to know this if you want to factor sum and difference of cubes. There's no way around it. So let's look at this first problem right here. So you have 27x to the third plus 1. So now we have a plus, which is good. So we know it's going to be the sum of cubes if it is a perfect cube. And then we look at these two terms and say, all right, are they perfect cubes? Now, the one thing that I forgot to mention was you always want to see if you have a common factor first. Because if you have a common factor, you want to take that out first before you look and do the sum and difference of cubes. In some cases, if you don't take out that common factor, you won't be able to actually do the sum and difference of cubes. You won't be able to do anything. So here, I don't have a common factor. So I just have to take a look at these two terms. So I got 27x to the third. That's a perfect cube, and then 1 is a perfect cube. And then I have, of course, the plus, so it's going to be the sum of cubes. So what I want to do is, for my a term, I have the cube root of 27x to the third, and that's going to be 3x. So basically 3x times 3x times 3x would give me 27x to the third. And then my b is going to be the cube root of 1, which is simply just 1. Once I find out a and b, now I'm going to plug them in to this formula right here. And you want to be careful, especially when you have a term like this, 3x, and you're putting it in and you're squaring it, the whole term has to get squared, not just the variable. And I'll show you how we set that up. So we'll go ahead and rewrite. We got the a plus b, a squared minus ab plus b squared. So of course it's good to write out the actual formula first before you start plugging everything in. So now when I plug it in for a, I got 3x plus 1. Plug in my a, 3x for that, and then my b is 1. Now I have a squared. Don't just write it like this, because that's not true. The whole term has to be squared. So it's 3x in parentheses squared. It means 3x times 3x minus a times b, so 3x times 1, and then plus b squared, which would be 1 squared. Now we want to go ahead and simplify this in here. And this typically is where the students make the mistake, right here. They'll just say that this is 3x squared, not that it's equal to 9x squared, which is what it is. So we'll go ahead and write that out. So we got 3x plus 1. This is 9x squared minus 3x. and then plus 1. And that is number 1 factored. Of course, you could multiply this all out to see if it equals this, which would be a lot of work. You got to multiply 3x times all 3 of these terms, and then 1 times all 3 of these to make sure you get that. But it is a way that you could check. All right, so let's look at number 2. Remember, the first thing I said is you want to check for a common factor. And we'll look at this problem right here. And we say, is there anything that we can take out? So you got 64 and 27. You have an x third here, but no x term over here. But I have a 1 y here, and then I got y to the 4th. So I could take out a y. So if I do that, that leaves me with 64 x to the 3rd plus 27 y, pardon me, y to the 3rd. Remember, teachers make mistakes too. And then if you remember when I did factoring before, when you take out that common factor, you want to circle it and you want to drop it down so that you don't forget about it. You don't want to forget about that factor. It's part of it. So you circle it, drop it down so you make sure you put it in the end when you're finished. So now I look at this right here. I got plus, so it has to be the sum of cubes. 64x to the 3rd, that's a perfect cube. 27y to the 3rd, that's a perfect cube. So let's go ahead, set that up. So a is equal to the cube root 64x to the 3rd, and that's going to be 4x. B equal to cube root of 27y to the 3rd, and that's going to be 3y. So now we're ready to plug into our formula here for the sum of cubes. So I'll write that first. Remember, it's always a good pattern to get into, habit to do that. So a squared minus ab plus b squared. And now we're going to plug this in. Remember that when you're getting to these square terms, put that term in parentheses because the whole term has to get squared. And I'm also going to drop down my common factor so I don't forget about it. So I got my y, then a plus b, so 4x plus 3y. And then I have a squared, so this is going to be parentheses 4x squared minus a times b, so 4x times 3y. And then finally I got plus b squared, so 3y squared. Seems like a really long problem, but it goes quick. So now we want to go ahead and simplify this. So we got y, and then we have 4x plus 3y. And now we want to square. So 4x squared, 4x times 4x, is 16x squared. And then when you multiply this right here, 4x times 3x, that's going to be 12xy. And then 3y squared, 3y times 3y, is going to be 9y squared. And then we are finished with that problem there. Let's look at number 3. And we have 81x to the 6 minus 24y to the 6. So now you see this minus sign, which you're hopefully assuming that it's going to be the difference of cubes. But remember, we also learned about the difference of squares in a previous lesson. So we have to figure out which one do we have. Well, either way, we got to take out a common factor. So looking at 81 and 24, do we have a common factor? We do, which is 3. So I'm going to take out a 3 here, and that's going to leave me with 27x to the 6th minus 8y to the 6th. So I take that out, and then what I say to do with that common factor? You want to circle it, and you want to drop it down so you don't forget about it, because we don't want to forget about that common factor. So now we look what we have. You got 27, and you got an 8, and you got x to the 6 and y to the 6. Now, x to the 6 and y to the 6 can confuse you because both of those are perfect squares, and they're both perfect cubes. But when you look at the numbers, 27 is not a perfect square, it's a perfect cube, and 8 is a perfect cube, not a perfect square. So we know we have the difference of cubes. So let's go ahead and find our a and b. So this is going to be the cube root of 27x to the 6th, which is 3x squared. And then we're going to do b, which is the cube root of 8y to the 6th, which is 2y squared. And one of the questions students will say is, well, how come you don't put the negative in here and do the cube root of the negative? Remember that we have the pattern up here. The signs take care of themselves in the pattern, so we don't have to worry about that. We just want to take the cube root of this term right here and of this. Don't worry about the signs. Again, they take care of themselves right in here. So let's go ahead and write down our pattern. So we have a minus b, a squared plus ab plus b squared. And we want to plug these in. Be careful when you're plugging them in here. You want to put them in parentheses so that you don't lose. You want to make sure you multiply it out correctly when you're doing that. And then I want to drop my term right there, my common factor. I don't want to forget about that. So now I have a minus b, so 3x squared minus 2y squared. And then plug this in here. So a squared, so parentheses, 3x squared squared. That's a whole lot of squared. And then plus a times b, so 3x squared times 2y squared. And then last, I got b squared, so 2y squared, so plus 2y squared squared. So there's a whole lot going on in there, which is why you want to make sure you're writing it all out carefully, neatly, so that you can figure this out and simplify it correctly. So I'm going to bring these down. So 3 times 3x squared minus 2y squared. So I'm good there. Let's multiply this out. So 3x squared squared means 3x squared times 3x squared. That's going to be 9x to the 4th. And when I multiply these right here, so 3x squared times 2y squared, that's going to be 6x squared y squared. And then finally, we have 2y squared squared. So again, that means 2y squared times 2y squared, which is going to be 4y to the 4th. And that is the final answer, which is long, I know, but it's the final answer. All right, well, hopefully you enjoyed this lesson, and there'll be definitely more to come, and you can check that out on my YouTube channel at Untitled Math. And like my first period students used to say, make smart choices. See you next time.